And you can see here how many people joined already. So 11 people. Okay. So is it the time? Yes. So hello everybody. Now it's 2:30. I welcome you all to our second hangout on the MOOC HIV science. We are happy that hopefully a lot of you can join us today. I'm Hilde, the community manager of that MOOC. And I'm very happy that we have meanwhile 4,040 students or registered people in that MOOC from 131 countries, with a majority in France, Cameroon, US, North and South Africa, but there are many more countries participating. We have been now finishing the 4th week of the MOOC. So week 3 was on HIV and the immune system, and week 4 on physiopathology of HIV infection. And today we cover the questions you have been posing in the last 4 weeks, more or less, with a focus on the last 2 weeks. And we will address them for you. Feel free also to ask questions here online in the chat or to join our hangout. Okay, I start with the first question that has been asked by Romusuku. What specific mucosal antibodies could block transcytosis, and how are they efficient in reducing infectivity of HIV-1?
Yes. Hi, I'm Asier Saitirion. I'm a scientist here at Institut Pasteur, and I'm one of the directors of this MOOC, and I hope that you are enjoying. So regarding this question, we translate the question to Hugo Munque, who was in charge of this section of the MOOC, and what he says is that it's not clear yet, or even controversial, what type of HIV antibodies could block the viral transcytosis across mucosal epithelia, when considering immunoglobulin subtypes, functions, and targeted epitopes. What appeared clear is that the neutralization of the incoming virus of virions at mucosal sites is crucial to confer protection by blocking mucosal transmission.
Okay, thank you very much. I hope this question is clear now. So we go to the next question, which addresses genetic diversity and treatment responsiveness. The question is, in week 1, we learned about genetic diversity of HIV. In therapy point of view, what is the real interest in HIV classification? Is there some group which are less responsive to some molecules or likely more resistant? Thank you very much for your response.
So again, the answer from Constance Delogier, who teaches this particular course on viral diversity, is that genetic viral diversity is going to impact treatment efficacy in only 2 cases. HIV-2 infection and HIV-1 group O, that are naturally resistant to non-nucleotide reverse transcription inhibitors, one of the classes of antiretroviral molecules that we have available. For HIV group M diversity, there is no impact on treatment efficacy, but the resistance profile could be different in case of virological failure.
Okay, thank you very much. Then we go to the next question, which has been asked by Sylvie. Hi, I have a question for Olivier Schwartz. Week 2, lecture 2. The diagram shows a decrease of the numbers of viral RNA copies upon treatment initiation. What about the pool of immune cells? In other words, does the treatment allow the host to reveal healthy immune cells that won't be infected by the virus from the reservoir? If yes, which is the kinetic of infection and type of cells that gets infected? Thank you for your response.
So the answer is that, well, it's a very large question, but the answer is that treatment initiation is going to allow the reconstitution of the CD40 cell pool. And this is actually one of the first benefits that is observed with control of viremia under treatment. The number of CD40 cell counts is going to increase. There is going to be reconstitution of different cells of the different subsets of CD40 cells. They are not protected by itself from HIV, but the antiretroviral treatment is obviously going to block new infection or new residing of the reservoir from the cells that were the infected cells that were remaining in the organism. That being said, that an efficient antiretroviral treatment is going to impair new cycles of viral replication. There may be some exceptions in some deep tissues, and this is subject of controversy today, because in some tissues in which the antiretrovirals don't enter as efficiently as in other tissues, perhaps there may be some events of viral replication that allow the persistence of the reservoir by new cycles of infection. But in general, treatment means stop viral replication. This helps the organism to reconstitute the CD4 T cell pool and impairs new infected cells, new cells to get infected.
Okay, thank you very much. We got one question online here in the chat from Anne-Sophie Liovat-Carnot. Hey, I can't be here for the session, but I have a question. Regarding the second presentation of Olivier Schwartz, he's presenting on diagram 7 the role of IFITM on endosomal fusion. That kind of fusion, and especially the representation that has been chosen, make me think about influenza fusion more than HIV fusion. So does IFITM also work on extracellular fusion? What is the level of endosomal fusion for HIV? Thank you and have a good hangout.
So thank you for the question. So actually, the works that have been performed with IFITM are mostly focused on direct surface fusion of HIV. And so IFITM is able to block this step on the first fusion step of HIV. The question about the endosomal fusion, so the membrane of the virus, virus can enter into the cell by two means: just directly fusing the envelope with the surface membrane of the cells, or this virus may be captured and then endocytosis, endocyte, and then fusion with the cell inside the cell with other or releasing the products and fusing with endosome within the cell. HIV is mostly entering the cell through a direct cell surface fusion step, and there has been some studies that suggest that HIV can also enter the cell through the endocytic pathway, but this is quite controversial. Actually, right now we don't know if this is a truly relevant physiological pathway. We still believe that the direct fusion with the cell surface membrane is the main pathway of entry, at least for CD4 T cells.
Okay, thank you very much. I hope that answered your question, Anne-Sophie. So we have a next question that has been asked by Virenda. Why are TFH cells in the preferential cell type for HIV-1 too high? Okay, I read the question. TFH cells being the major reservoir of HIV-1 in patients, what is the differential molecular mechanism in TFH cells as compared to memory CD4 plus T cells, which keeps HIV-1 in latency? Also, how these reservoirs expand as compared to what happens in conventional memory CD4 plus T cells, which is reservoir expansion or low level of viral replication, is possible in TVH cells as well. If possible, can these differential molecular mechanisms in TFH cells be targeted to induce HIV-1 reactivation or to reduce HIV-1 reservoir in HIV-1 patients?
So there are several parts to this question, and actually some of these questions we don't have the answer yet. What is true is that TFHs are thought to be a major or represent a major part of the persistent reservoir in HIV, but for different reasons. First is that TFH can be infected by the virus. They have characteristics that make them highly susceptible in terms of activation and also localization. They are going to be found in the lymph nodes where there is a major site of viral replication. Then there are other circumstances that make them particularly difficult to eliminate. And one of them is that the TFH are going to be localized in sites of the lymph nodes that are not accessed by, for instance, cytotoxic T cells. So they are ignored by the immune system. They are not really eliminated like all that even if they are in contact with some of the responses, they may block somewhat the action of this immune response. So this is mostly, they are not particularly perhaps the most susceptible cells, but they are in places that are immunoprivileged in some sort. Whether we can target them and to specifically eliminate them, this is something that is being pursued by several teams trying to characterize several factors that are unique or particular to target specifically these cells to eliminate them from the body, or even redirecting some of the immune responses that are not going to the lymph node follicle where these cells are, so that they can be killed by the immune system. I think that mostly covered it.
Thank you very much. So we got another question by Eril Edru. Thanks to Hugo Mouquet for his exciting review on recent developments on NADs. According to the vaccine-like effect of these AB, observation of a broader endogenous neutralizing AB response in some patients at distance of the passive transfer, could an idiotype, anti-idiotype mechanism be involved if this theory is still up to date? It's anyway, if confirmed, a very interesting link between passive immunization and vaccination.
So thank you for the question. Again, we translated the question to Hugo Mouquet, and his answer is that it's very unlikely to originate from an anti-idiopathic mechanism. As to his knowledge and to mine, no antibody response has been detected in treated individuals against the passive infused molecules. The origin of the phenomenon may lie in the fact that administered broadly neutralized antibodies form novel immune complexes with viral variants that were never presented before to the immune system. And these immune complexes then allow the selection, proliferation, and activation of cross-reactive B cells and or plasma cells through an avidity effect. And also, there may be some expansion of CD8 cells through the same mechanism. So it could be vaccine-like effect of the antibodies, but through the formation of immune complexes and priming or new responses. And if you want more information, you can look for a recent review by Hugo Mouquet, Cold Spring Harbor Perspective Biology, published this year.
Questions here, audience? If so, please post them now here in the online chat. And otherwise, if there are no questions, so far we covered them all, we want to say goodbye for today's Hangout session. The next Hangout will cover week 5, clinical management, and week 6, the perspectives and future challenges on HIV science. And the next Hangout will be the final Hangout, and that will take place on Wednesday, 19th December 2018 at 2:30 p.m. Central European Time. And I still cannot see any other question. So I think that's it for today, and we look forward to the next Hangout. Have a nice rest of the day. Bonne journée. Bye-bye. Au revoir.